value? What does it say right here? What are we finding for the inside the parenthesis? What operation are we doing? I've got it highlighted and I've got my screen frozen because I want you to look up there. What is in that parenthesis? What is the operation up there? What does it say inside the parenthesis? 1 minus r. So we have to do 1 minus r. Well, what is r? We just calculated it. 0.14. You're right, 0.14, 0.14. It's the same exact thing to the power of t. So which equation to the left matches this? Which equation to the left matches this? C. No, it doesn't. That's not minus. D. 1 minus 0.14 is 0.86. So if you don't have everything that I've written down on our paper, either on your little yellow worksheet or on your scrap piece of paper, you're not going to get the credit for this, okay? So you're working along with me as I go through it. I'm not going to wait for you guys to sit and watch me work and then want me to pause for you to catch up. That's not how this is working. And I am recording it. So if you don't get it, you can fill it out later. Number 5, a lab worker monitors the growth of a bacteria colony starting at 9 a.m. At that time, there are 100 bacteria. According to the exponential function, f of x equals 100 times 4 to the power of x, the bacteria quadruple every hour. What is the value of f of 0? What is that asking me to do? What's it asking me to do, Caden? When it says f of 0, what does that mean? What am I replacing with a 0? X. I'm replacing x with 0. So my equation for f of 0 is 100 times 4 to the power of, there's where my x is, so I have to put a 0 there. So put that into your calculator. What do you get when you take 100 times 4 to the power of 0? You get 100. Again, if you're not showing the work, you're not going to get the points back. Number 6, the population of Jacksonville in 2018 is estimated to be 19,000 people with an annual rate of increase of 3.4%. Which equation models the population of Jacksonville? So is this going to be a percent growth or percent decay? This is growth. So what is the equation for growth? What is the to the power of t? So what do I have to do with my r? What is my r value, Ashton? Do you remember from the last question how we find r? No, it's you take your percentage and you do what with it? How do we have to take our percent and turn it into a decimal. So we do that by dividing by 100. So 3.4 divided by 100. Yeah, 0.034. So what is our initial value going to be? What is the value of A? Yeah, no, A is 19,000. A is 19,000. So what's our equation going to look like? So y equals, hang on, slow down. Y equals what? 19,000. Parenthesis, keep going, Jaden. Nope. Yeah, 1.034. Don't forget you got to add that, right? To the power of t. So what answer should we have chosen for this one? D. We should have chosen D. All right. Number 9. Number 9, the function f of x equals 5 times 1.24x models the length in centimeters of a lizard each week from the beginning of the lizard's life. In the model, which term represents the number of weeks of growth? Say it again, Hayden, so everyone can hear it. X. Why? Can you explain why? How big is the lizard when it's first born? What's the initial value of it? Yeah. So when it's brand new, first week of life, it's 5 centimeters. Okay. So when initial value, sorry, first week, 5 centimeters, brand new. What is my multiplier? So this is my A value. What is my multiplier? Do you guys know? Yeah, 1.24. That tells me how much it's growing each week. It's growing by 24% each week. So X represents the number of weeks. And what does Y represent? Or f of x in this case? The 1.24 is the multiplier. What does Y represent? When we do all this math, when we take 5 times 1.24 to the power of x, what do we get? What do we get? The length of what? Yeah. So the f of x or the y value represents the total length of the lizard. The total length of the lizard. Okay. Number 10 says the function, same thing, f of x equals 5.124x models the length in centimeters of a lizard from the beginning of its life. According to the model, which represents the length of the lizard at the beginning of its life? What represents the length of the lizard at the beginning of its life? Yeah, A equals 5. So that answer is 5. So we described everything in the first one. We said what happened. So 10 is A. Your A value is 5. Those lowercase k. All right. So 2 of these questions, number 11 and number 16 came right from your review. And so did number 17. 11, 16, and 17 came right from your review. So consider that 15 times 1.055x shows the balance in a savings account over time with no additional deposits. Which statement is the best interpretation of one of the values in this function? So we're going to first of all pick apart the function. So let's just think of this as f of x equals 15 times 1.055 to the power of x. And we're going to say that x equals the number of years. So What does 15 represent, Uriah? The initial value. Good job, Uriah. So A equals 15. It's the amount that the account was started with. That's how much money it's, if you want to think of it as the initial deposit. It's the initial deposit. We didn't put any more money in there except the initial deposit. Okay, God bless you. So that 1.055 tells me what? We have to turn that into a percent. So think of this as your multiplier, but because this is growing money, this came from 1 plus R. I need to figure out what R is. How am I going to do that? The 1.055 came from the expression 1 plus R. Nope. I want to find out what R is. How am I going to find out what R is first? Hayden, where are you getting the 0.55? Yes, I'm asking you, how are you working with, explain to everybody in this room why you're just working with the 0.55 instead of 1.055. Because we added the 1. So in order to find the rate in its decimal form, we have to subtract the 1, right? That's how we did this. We have to subtract the 1. So 1.055 minus the 1, which is what we added here, tells us that our rate as a decimal, this is my rate as a decimal. So keep going, Hayden. Then multiply this by 100 because we're taking it from its decimal form back to its percent form. So what does that give me? Yes, sir. 5.5%. So which statement to the left is going to work for this? B, the savings account earns an annual interest rate of 5.5%. Good job. Number 15. Okay, give the equation of the exponential function in the form y equals a times b to the power of x that goes through these 2 points. So look at your journal where we were constructing an exponential function. It is the color of blue. Constructing exponential functions. It's the blue one that you cut. Some of you cut it in half. It's the blue one. How do I write an exponential equation just given 2 ordered pairs? Yeah. This is the form I have to write it in. But how do I do that with the 2 ordered pairs? What do I need to find? How do I start? If my ordered pair, if I'm not given an ordered pair that says 0 and some number, right? Because if I had an ordered pair that has 0 and some number, that would be my A value, right? The ordered pair 0A. Do you guys remember that? That would be my A value. But I don't have that ordered pair. So I have to figure out something else because I don't know what A is. Is there a way that I can figure out the value of B? No, you're fine. Yeah. I know where her room is. Yep. Yep. Yeah, no problem, ma'am. Hun. Bye-bye. Okay. Ah! Okay. So if we can't find A from our ordered pair, what do we have to find next? B. We did this with geometric sequences and with exponential functions. I'm going to write my two ordered pairs like they're in a table. I have the ordered pair 2, 81, and I have the ordered pair 3 and 243. B is the what value? B is the what? What did we call B? What does B stand for? No. B is my what? I'm writing it up there. What is B? B is my multiplier. B is my multiplier. So what did I do to 81 to make it equal 243? You guys remember with your geometric sequence, you just take the second term and divide it by the first term, right? What did I multiply by? 3. This is times 3. So that means that B equals 3. Okay, so we know what B is. All right. How are we going to find A? This was the sequence idea. I just want to find A, just A right here. I want to find the initial value. Divide what by 3? Well, 243 divided by 3 is 81. Look at your blue paper. What did we do with that ordered pair? We picked an ordered pair and we did what with it, Zan? So you want me to work backwards on my table? I love that idea. We could. Yeah, we could. So 1, Zan, keep going, and 0. So instead of multiplying by 3, what do you want to do, Zan? So Zan, what is 81 divided by 3? 27. Okay. And then if we want to find A is our initial value, and that happens when x equals 0. So we have to divide by 3 again. 9. Good job. So what is the equation that I'm writing over here? What numbers, because this was a drag and drop for you guys. What numbers are you dragging and dropping into your equation? What comes first? 9. And then in the parenthesis, 3. This had 87% in miss, like failure rate. 87% of the students missed this question, and I don't understand it because we did so many of these. Last 2 questions. And this came right from our notes and right from our homework. Same exact graph even. Engineers are draining a reservoir that holds the water and are tracking the depth of the water still left in the reservoir. The graph below models the rate at which the water is draining. So we have to do 2 things. We have to create an exponential model, okay, for the graph, rounding B to the nearest hundredth. And then we have to say what the value of B represents in terms of percent growth or decay. So let's look at our graph. What is some information that we can get from our graph? Say again. I can't hear you, honey. The points, we need to use those points. Absolutely. What do those points tell us? The depth of the water. Okay. So do we know how, like what the depth was when it first started? What? So that means that what is 45 in our equation? A. That means A equals 45. Because that came from the ordered pair 0, comma, 45. What else do I have to find? I have to find B. How am I going to do that? Well, what did we just do in our table above to find out the multiplier? What did we do? Divide backwards. So we took the second term and we divided it by the first term on the y values. We took the second y value and divided it by the first. And we want to leave that as a what? Just give it to me as a decimal because we're going to end up rounding it. Is that what everybody got? 0.53 to the nearest hundredth? Hundredth is 2 decimal places. Did anybody else get 0.53 or is Jaden the only one? You got it? Okay, so we're going to use 0.53. So the first part says write your equation. So we have to fill that in. So it says the value of B rounded to the nearest hundredth is what? 0.53. The value of B rounded to the nearest hundredth is 0.53. It says the value B represents a blank. This is going to be a percentage number and either the word growth or decay. So is it growing or is it decaying? It's decaying. So the word here is going to be decay. We need to figure out the percent of decay. So when we talk about decay, this number right here came from 1 minus R. 1 minus R equals this. 1 minus R equals this. So how do I figure out what R is? Write it down. It's just an equation. We're going to get R all by itself. How do I get R all by itself? First. Can someone let Ms. Durbin in? How do I get R all by itself first? I have 1 minus R equals 0.53. I want to get R all by itself. What do I have to do? It's a positive 1 right now. So I'm going to subtract 1 from both sides. Subtract 1 from both sides. And when I do that, I have negative R equals, what is 53? Sorry, what is 0.53 minus 1? Is it a positive or a negative 0.47? It's a negative. So negative 0.47. So negative R equals negative 0.47. What do I have to do next? So I want positive R. How do I take that negative R and turn it into a positive R? What do you think, Seamus? What do I divide everything by to get rid of that negative in front of my R? Yeah, we're going to divide by negative 1. Divide by negative 1. So negative R divided by negative 1 gives me positive R. And negative 0.47 divided by negative 1 gives me a positive 0.47. But it says we have to represent it as a percent. And I even made sure that this word was like nice and bold in the question, a percent of growth or decay. So how did we turn the decimal into a percent in the 2 questions above? Yeah, good job. Times it by 100. So what is our percent of decay? Yeah. So that's what's going to go here. So I'm going to shrink this up for a second because remember, if we don't have all this work on here, you're not getting the points. If you don't have all the work, you're not getting the points. We have one more question. One more question. And this is the last question that I took directly from your homework. Okay. Are we ready? Hi. So it says, consider the function f of x equals 150 x plus 250 and g of x equals 5 times 3 to the power of x. It says, how much greater is f of 3 compared to g of 3? So that's the first thing that we need to find. What does that mean? What is it asking me to do, actually? What do you think, Braden? Tell me what it's asking us to do. Huh? Yep, run A. What do you think, Matthew? When it says f of 3 or g of 3, what is it really asking me to do? Okay, I want both of you guys to close your Chromebook. Because Matthew, you're typing some email or something and I'm over it. And Braden, I keep seeing you switch your screen. So close it. All the way. Thank you. Caden, what does it mean when it says f of 3 or g of 3? It's the second question we've done like this. We take the what and replace it with a 3. Yeah, the last one I gave you was a 0. Do you remember that? So we're going to get rid of the x in both of these functions and replace it with a 3, and we have to evaluate it. So here's what our work is going to look like. For the f function, f of 3 equals, well, that's going to equal 150 times what? What am I replacing the x with? A 3. So that's going to look like 150 times what? 3 plus 250. So someone put that into their calculator and let's actually don't shout that out. You just figure it out. Figure it out. We'll talk about it in a second. I want everyone to figure it out. No shout outs. So pick up your calculator, do that math. Uriah, what about the g of 3? What is that going to look like? How am I going to substitute that in? What's that going to look like for g of 3 in my function? What am I going to do? What am I going to write? Look at your g function. G of x is what? Do you see your g of x function right here? So if I want to evaluate it for g of 3, what is that going to look like? What do you want me to write down? To the power of what? But I don't want x. I want g of 3. Do you see how it says evaluate g of 3? So what am I doing? What am I getting rid of and putting a 3 in its place? So I'm going to put the 3 right here instead of the x. Does that make sense? Okay, I want you guys to evaluate that. Plug it into your calculator. Write it down. Plug it into your calculator and write it down. So once you get that written down, we're going to go back to question A. I don't want any shout outs. Question A says, how much greater is f of 3 compared to g of 3? Carla, what does it mean when I say how much greater? What is that actually asking me to do? Like if I asked you and Jansen to stand up and I wanted to know how much taller you were than Jansen, what would we do? We would have to take your measurements and do what with them? Subtract them. So here's what I want you to do. I'm not giving you the answer, but you need to take whatever you got for f of 3, and from that answer, I want you to subtract your g of 3, and that's what you're putting in this box. That's what answer A is. How much greater is f of 3 compared to g of 3? Yes. So when you did f of x, where's your work for that? Let's do that again. What's 150? 150 times 3 times plus 250 plus 250. What is your answer? Okay. So then remember what I said I want you to do. I want you to take f of 3 minus g of 3, and that's what A is, okay?
Which you're supposed to. So you're gonna do this minus that to get your answer.
Are we ready to do B? Yes, we're good?
This and this. You do this minus this. What'd you get for this? When you multiply this, what'd you get?
You have to say, this says 150 times 3 plus 250. So write that number down where it says f of 3. Okay, and what you get for g of 3? Is that what you got? Okay, so when you subtract those, what is the g of x equation? What does that say? 5 times 3 to the what? Do you see what I wrote up there? 5 times 3 to the power of what? Okay, do you have that there? Or you calculate that again in your calculator? 6 is not right. Put that in your calculator. Just like you wrote it right here. Enter. That's what you need, right? And then I want you to subtract the difference. Find the difference. Okay. Last part of this says the value of g of x will eventually exceed the value of f of x. The value of g of x will eventually get bigger than f of x. We need to find out when, between what two values, okay? So you guys are going to go to Desmos, or you can use your x, like your y equals in your calculator, but I think it'll be easier in Desmos. You're going to go to Desmos and you're going to put both of these equations into Desmos. You're going to put both of these equations into Desmos. You guys were able to use Desmos on your test. And then you're going to pull up a table. So I want you to go to Desmos Graphing. Desmos Graphing. And I want you to input your equations and just use, you can use y equals for both of them, but you're going to put a table under each one. So I'm going to type this first one, y equals 150x plus 250 like this. Y equals 150x plus 250. And then I'm going to ask for a table, right? We've done that before. And I'm going to just give myself some numbers, 4, 5, 6, 7. I want to see when the g of x gets bigger than the f of x. So this is my f of x equation. So now I'm going to add another equation into Desmos because remember you guys were able to use that. So y equals 5 times 3 to the power of x. And I'm going to go back up here and say, hey, I want a table for this as well. And I'm going to just do the same thing. 3, 4, 5, 6, 7, 8. And I'm going to compare my tables. And I want to see when the f of x is, when the g of x, when my function at the bottom is bigger than f of x. And it happens in between two integers, So build your equations first. Into Desmos, and then I'll just come around and help you think about it. So put your equation. Nope, you have to do your equation first. You start with your equation. So y equals 150 x plus 250. So click on this for your table. So I would go down 3, 4, 5, 6, 7, 8, 9, something like that. Okay, here you go. Okay. Now let's go to the next function. 5 times parentheses, so 5 parentheses.
Were you able to just use the gears?
3. Shift 6 x for it. Okay, and go back up to here. Get a table.
See?
Okay, so get some more numbers down there. You're not starting with the table, you're starting with an equation, and then you hit your gear. Okay, so you want to compare. When does this function between what two numbers does your g of x get bigger than your f of x? Okay.
Okay. Use this.
So
Table.
first function.
Okay.
So x equals 1, 5.
Okay. Now, plug in another one.
5, 0. Okay, that's my first equation. Click on your gear
That one.
and get that table. Put some more numbers in there. I went all the way up to 8. So if you just hit enter, it'll start populating them for you. You see that? Okay. Now you put in your g of x function.
This one.
So the gear, table, and you want to give it more values. And if I just hit enter, it'll
You're ready for the X.
now you're going to do the g of x. Okay? I want you to compare. I want you to tell me when the g of x between what two numbers?
Okay. So then you want to get a table for that.
So when this is 5, that's at what did you say? Okay, and when it's at 6, it's at what?
3.
Okay, so between what two numbers? Did that just happen? Okay. You understand what I'm asking you to do? What is g of x? G of x is actually, so
Click the gear. here's your function. G of x is 5, the power of x. Okay, when you want a table for this, right? I want to put more values in there, I just hit the enter and you'll keep going. That's your G of x function. Then look at your linear function, or f of x. So I'll put that right now. F of x. Now, here's your there you go. There you go. A little more. There you go. 150 x plus 250. You're gonna hit your here again. And then just add some more values here. There you go. Okay, so this is my linear. So start looking at 4, 5, 6, 7, 8. See what your values are. This is the linear function. The question is, when is the geometric or the exponential function up top? When does this function overtake? Because right now f of x, when x is 3, the linear function is bigger than the geometric. When does the geometric or the exponential function get bigger? That's what's asking me. Between what two numbers? Okay. Once you guys are finished with that, put your name on your paper and I'll take it. Put your name on it and I will take it. Did you do any work on your paper? You still working? Okay. Names on there? Perfect. You're amazing. Would you do me a great big favor? Rise and I'll come back in about a second. You really that one too? This one, yeah. Thank you. Will you do this one for Aiden? Thank you. Got it? Perfect. Got it figured out? No? Okay, so do you have your tables built? This is your, okay, let's go. You want to build your equation. You start with the equation first. So f of x, thank you so much, dear, equals 150x plus 250. Once I okay, once I have my equation built, I can click on that here and I want a table. I want it to calculate my values for me, right? So I'm just gonna get some numbers. Now I'm gonna do a new equation. I want you to put in your g function, which is g of x equals here.
So when the value here get higher than the values here.
So you're going to compare the exponential function. What do you say to the linear function? Like x is 4, the
When do the y values of this one get higher than the y values?
Yeah, we're just gonna keep going back and forth, finding out what number does it start to get bigger, between what two numbers? Okay, so let's see, when x is 4, your exponential function is at 405, and what's your linear function at? Go back up, linear. When x is 4, it's at 800, so the linear is still bigger. So what about when x is 5? The linear is at 1,000.
You're looking at these, okay, when are these
This one bigger.
higher
So it happens
than the ones for the other function, for this? When do they get bigger? At 3, what? Okay, and this one at 2.
You gotta start with where is the.
So that's not bigger.
Linear is bigger.
At 3,
This
then
that's bigger with the g of x.
Yo.
And then the next number.
when are these?
name on here? Is that the first time it got bigger?
Hey guys, you guys remember you have a Delta Math 6-1 through 6-3 review. If you finished your test corrections, I will take those. 6.1,
That was
6.3.
that 565.
Help? Okay. So are you?
There. That was
Try to read it.
that. They would finish it off with anything else.
Okay, so I want your table.
Okay. Now,
You're what?
so I'm gonna start with linear.
What is
You
that?
know, at 3, the linear.
Oh, no.
All right, let's check it. 4. Oh, you want 3, 4, 5. Linear, so it happens when it's 5. 5. So that's where it happens. Now that we have the table here. Let me here. This. Why does it get larger and why does
Okay, Delta Math, you guys have 10 and 15 minutes. Everyone should be in Delta Math. I'm not sure why we're all packed up. I just said that. Delta Math. You have a 6.1, 6 through 6.3 review. That is what you should be working on. Did I grab your? Yes, you may. Can you write yourself a pass? Thank you. Did you guys finish? Still working. Done? Or you're still working? Oh, I'm still recording. I need to stop that. Okay. I got you. So, do you want me to stop it and post it really fast for you?